All right. So, hi everyone. My name is James Chung. I am a first year medical student, and I'm going to be discussing some basics of nutritional concepts with you today, including carbohydrates, sugar, and diabetes. So I think we all kind of intuitively know what carbohydrates and sugars are just from what we've eaten. We know that they're found in things like breads, pasta, potatoes, pancakes, cereal, fruits. They're also found in sodas and granulated sugars and all those kinds of things. But what exactly is the difference between a carbohydrate and a sugar? Um, so to give you a little bit of background in terms of the chemistry of carbohydrates, we can start with glucose. So glucose and fructose are monosaccharides. So monosaccharide means like single sugar. And so these are single unit sugars, glucose being the type of sugar predominantly found in blood. And so if we take two monosaccharides and we connect them, we form what's called a disaccharide, so two unit sugar. So examples of these include things like sucrose, lactose. So sucrose would be table sugar, lactose is in milk. And if you take a single unit sugar like glucose and you chain it together in this long chain and it branches out and just gets very complicated, these are polysaccharides, so many sugar units. These are long chains of monosaccharides connected together by chemical bonds, and these are known as complex carbohydrates. These make up things like potatoes, vegetables, bread, etc. And so this is just a little bit of basic background on what the difference between simple sugars and complex sugars are. But so how does the body actually use the carbohydrates that we eat, right? So we have these things called enzymes, amylase, lactase, maltase. As you can see by the naming convention, they typically end in ase. And see, these are things produced by the body that can break down the polysaccharides that we eat. So say we eat a piece of bread. The polysaccharides in that piece of bread are going to be broken down into disaccharides and monosaccharides. It's going to break it apart into little chunks. Eventually, this process will continue until we get single unit glucose molecules. This glucose enters the bloodstream where it triggers a rise in the hormone insulin. This is released by the pancreas. Now, this insulin hormone is very important, and I'm going to be discussing more of it later. So put it in your back pocket for now. So insulin stimulates the cells found in muscle, liver, and fat tissue to absorb the glucose. And that glucose, once it's actually pulled up into the cell, they can use it for energy. So once the glucose is in the cell, how does the cell actually use the glucose that it absorbed? Well, you probably heard about the mitochondria, the powerhouse of the cell. It's kind of a meme in biology on social media and all these different places. But basically, the mitochondria is the powerhouse of the cell because it can efficiently convert that glucose it pulled up into huge amounts of ATP. And that ATP can be used as the primary energy currency for pretty much all cells in the body. And so this is pretty much how we live, how our body does its day-to-day functions is through this ATP. If you're wondering what these little green squiggle things are in the bottom of the slide, that's one of the more interesting things I learned in medical school is that mitochondria don't always present as these little bean-shaped things like you see in diagrams. They actually can come in different shapes, including these tubule like worm structures. So I thought that was pretty interesting. So now that we have a basic understanding of what's going on from like a zoomed out view as well as a cellular view as to how the body is using carbohydrates and sugar, so what happens when parts of this complex system fail, right? Well, we get something called diabetes, which has two types, type 1 versus type 2. And so type 1 diabetes is caused by the loss of the body's ability to produce insulin. And remember that I said that was a very important hormone. So what this means is that the sugar that you eat, the carbohydrates that you eat that get broken down, that are ready to be absorbed from the bloodstream, the body can no longer remove that glucose from the bloodstream anymore if it cannot produce insulin. And so this is treated by simply giving insulin shots to correct the lack of insulin. Type 2 diabetes is quite a bit more complicated. and is caused by the loss of the body's ability to use the insulin that it has. So it is still able to produce insulin. It's just that the cells don't respond to the insulin in the same way that they normally should be able to. And this condition is more related to genetics, lifestyle, diet, age, as well as other factors. So that's the primary difference between the two types of diabetes. And so just so you get a sense of the complexity of type 2 diabetes, it's not quite as simple as say you eat a high sugar diet for a period of time and you automatically get type 2 diabetes. There's a lot of different risk factors that the research has identified as playing a role in the development and diagnosis of type 2 diabetes. So genetics is one of them. Genetics are very strongly linked to type 2 diabetes. Sedentary lifestyle, being overweight or obese, particularly if that obesity is centered around like the abdomen. Certain racial and ethnic groups are also at an increased risk for developing type 2 diabetes. As well as, interestingly enough, smoking is a risk factor for development of type 2 diabetes. Unhealthy dietary lifestyle, I think most people kind of understand that. And age. So typically, the older you get, the higher your risk for developing type 2 diabetes becomes. So these are just some of the factors that can all play a role into developing type 2 diabetes. So can we prevent or delay type 2 diabetes? And the answer is yes. So we can. We can at least control some of the factors that play a large role in the development of the disease. So the first would be to maintain a healthy body weight, right? So people who are overweight, especially if they're carrying excess belly fat, that's central abdominal adiposity, they are more likely to develop insulin resistance, leading to type 2 diabetes. So maintaining healthy body weight is definitely very important. Physical activity is another one that's kind of underappreciated. So 150 minutes of moderate aerobic exercise per week meets the guidelines for aerobic exercise, as well as a minimum of like 2 strength training sessions per week that hit most of the major upper and lower muscle groups of the body. So this can also substantially decrease your risk for developing type 2 diabetes, as meeting these 2 criteria for physical activity. And of course, like as far as the dietary pattern goes, you definitely should aim to increase fruit, vegetable, and whole grain intake, as well as focusing on like things like lean protein sources, some dairy, other things like that. And in general, trying to minimize consumption of things like high sugar foods and beverages like soda or juice. Those things definitely need to be kept to a minimum to maintain a healthy dietary pattern. And here is a link from the CDC to kind of go over all of those things that you can modify. So I hope you found this informative. This is just kind of a basic overview on carbohydrate science, carbohydrate metabolism, so how we use carbs and sugars, and the implications in terms of disease if there is an error or a malfunction in a piece of that larger system that controls how we use sugar. So, all right, thank you for watching.